Today we are going to discuss skill builder program on the organic compounds containing oxygen. So we are going to discuss a series of problems, and the problem set is already available with you, and we will go for as many questions as possible that are given in the problem set. Let us now go to the question number 1 in the question number set. The question asked is, how will you convert, this is actually 3-chloropropanyl, that is actually the name that is given. How will you convert 3-chloropropanyl to glyceraldehyde? So first of all, we should know what is glyceraldehyde. Glyceraldehyde is just this compound. Glyceraldehyde is an aldehyde. One of the glycerol is actually CH2OH, CHOH, CH2OH. So one of the alcoholic groups, the primary alcoholic groups, is being oxidized to aldehyde. This is known as glyceraldehyde. This also contains a chiral center. This carbon is a chiral center. So this is the information about, this is some basic information about the compound. This is what is known as a target molecule. What we are going to discuss, what we are going to prepare is referred as a target molecule. How will you prepare that? When you look at this compound, you will find we will have to introduce 2 hydroxyl groups. Now, if 2 hydroxyl groups are to be introduced, you must have a double bond that should be there between the 2 carbon atoms. So how will you first do that? So in order to get a double bond here, you must do a dehydrohalogenation. But we have to do it in the presence of an alkali. But in the meantime, when you do this, this should not get affected. Supposing in the presence of alkali, if you do a dehydrohalogenation, this may undergo some aldol condensation or some other related reaction affected by the alkali. Therefore, this CHO has to be, as a first step, protected. So that will be the first step. We will go through the steps. CH2, CH2, CHO plus you make use of ethylene glycol for protecting the alcoholic group. the aldehyde function, the CHO function. This is usually not done in aqueous medium. This is done in dry HCl. It is very important to use the word dry HCl. If you use aqueous HCl, this reaction will not work. The acetal or ketal will be formed and then will be hydrolyzed back to the free aldehyde. So what we get, this will be, nothing of this will be affected, only this will get protected. So what we get will be CH2Cl, CH2, this CH will become a protected aldehyde. There is no longer any aldehyde group here. This aldehyde group is now being protected by means of ethylene glycol. This is what is known as an acetal. Normally, if it is a ketone, we call it as a ketal, and if it is an aldehyde, it is called as an aldol. This is an aldol. This is a protected aldol. Now, the aldehyde group is now totally protected and will not undergo any reaction. This will not be affected by alkalis. This is sensitive only to acids. Now, you do the reaction with hot alcoholic potassium hydroxide. With hot alcoholic potassium hydroxide, this will lose a molecule of HCl to give, this is minus HCl. This minus HCl will be lost to give CH2 double bond CH, CHO, CO, CH. Now what we do is, we have a double bond here. Our object is to introduce 2 OH groups here. It is very easily introduced by means of Bayer's reagent. Bayer's reagent, as we all know, is 1% alkaline, dilute alkaline permanganate. So you will get Bayer's, this compound CH2OH, CHOH. This is a protected aldehyde. When you hydrolyze this, simply treat it with water, acid conditions. This will become a free aldehyde. CH2OH, CHOH, and then CHO. This is exactly the molecule which we want to get here. This is the target molecule. So we have to go through this step. The most important step in this connection is, we will have to protect this aldehyde in the form of an acetal, then do a dehydrohalogenation to get the olefin, then hydroxylate that olefin, you will get a diol, and then after that you cleave this acetal to give rise to the free aldehyde. These are all the various steps that are involved. About 3 steps are important. I mean, this will be the shortest route to the conversion of this compound to the final target molecule.